Chapter 2, number 30, we have the position of a person is given by x equals 4.0 t minus 0.5 t squared, where x is in meters and t is in seconds. This is chapter 2, number 30, and we have this equation for a position. X is equal to 4.0 t minus 0.5 t squared. What is the average velocity between t equals 0 and t equals 8 seconds, between t equals 8 seconds and t equals 10 seconds? To answer this, we need to know the definition of average velocity. What's the definition of average velocity? It's what? That's instantaneous is the derivative. So, yep. Velocity is equal to change in position over change in time. So that's some final position, I'll call it x final, minus your initial position, divided by the final time, minus the initial time. In part A, they ask us to find the average velocity between t equals 0, so t initial is 0, and t final is 8. Okay, so I look at my average acceleration or average velocity equation. I need t final and t initial. I have both of those. What else do I need to be able to plug in and solve this? Need x final and I need x initial. Can I get those? Yes. I can. So x final is going to be x at 8 seconds. So I plug in 8 for t. Everywhere I see t, I plug in an 8. So I get 4.0 times 8 minus 0.5 times 8 squared. What's 8 times 4? 32. 32. Minus 0.5 times 8 squared. What's 8 squared? 64. What's 64 times 0.5? 32. What's 32 minus 32? 0. My final position is 0. What's my initial position? 0. What's my final position minus my initial position? 0. So what's my average velocity over that time? 0, because it's 0 over 0. Okay? It's not it's maybe a little tricky. Yeah, it's not as hard as it might seem. Okay. So how would I find the velocity between 8 and 10 seconds? Yep. Make my final time 10 and plug in 10. Make my initial time 8 and plug in 8, and do the equation. Yes.
On the test, will you be deducting points if you don't put units? Because then you get 0.
So yes, that's a good question. I would deduct points. So I would have missed like half a point on that one. Meters per second. How many sig figs should be in the answer according to the numbers that you're given up at the very top? 2. Are there 2 sig figs here? Would I lose points there? Only if I said obey sig figs for this problem. Okay. So make sure when you're going through and reading the directions, read the directions. Do what they say to do. Something I've never done on any of my exams, so people that have taken a previous class with me, this is a little bit of a change. I now have in the instructions, you have to have organized work and you have to circle your final answer. If you do not circle your final answer, I will not grade your problem. And you will get 0 points on it. Even if everything's right and you get the right answer. If your final answer is not circled, I will not grade it. Okay? Okay. Then I don't have to go digging through and find things. All right. So that was problem number 30. Yeah. Hopefully not too bad. Let's also do problem number 37. Chapter 2, problem 37. This is going to be similar to problem number 30. We have a football player that kicks a stationary ball and sends it flying. Slow motion photography shows that the ball is in contact with the foot for 8 times 10 to the negative 3 seconds. So right away I have some time that's 8.0 times 10 to the negative 3 seconds. And the ball leaves the foot with a speed of 27 meters per second. So I'm going to call that V final because the ball is leaving your foot. V final of 27 meters per second. What is the average acceleration of the ball while in contact with the foot? What's the definition of average acceleration? Change in V over change in T. So I have V final minus V initial over change in T. Let's see if I can plug things in. Do I know what V final is? What's V final? 27 meters per second. What's V initial? Do I know V initial? What is it? Why is it 0? Ball's stationary to start with. 0. Multiple people asked about this question. Okay, that's why I'm doing it. Change in time. Do I know the change in time? What's the change in time? Yeah, it's lunchtime, so a lot of your 8.0 times 10 to the negative 3 seconds. Am I missing anything? I have all these numbers, right? Can you plug these into a calculator? Yes, you can. And you will find your average acceleration is equal to, this is number 37, 3.4 times 10 to the third meters per second squared. Boom, I even use sig figs, even though I didn't have to. I'm trying to impress the teacher. Okay. Chapter 2, number 37. Very similar to number 30. Just know the definition of average acceleration and you can plug in and get things. Yes?
Would you mark this off that we just had 3,400 meters per second squared?
No. You don't have to write any scientific notation. Unless I tell you, write this in scientific notation. All right, let's do another one. Let's do problem number 41 in chapter 2. Chapter 2, number 41. The position of a particle in meters is given by the following formula. X equals 3.6 t squared minus 2.4 t cubed, where t is in seconds. Find the 2 times when the velocity is 0, calculate the position for each of those times, and then sketch x as a function of t for t greater than 0, less than 2. I'll go ahead and say right away that last part where you have to draw sketches. Since I don't know that everybody has a graphing calculator, you won't have to draw sketches on the exam. Okay? You might have to interpret sketches. I might draw sketches and you might interpret them, but you will not have to draw the equations. So the first part of this problem is asking us to find the 2 times when the velocity is 0. Is that a velocity equation? No. Can I get a velocity equation from that? How? I take the derivative. So if I take the derivative of this for part A, velocity is dx dt. And I can take that big fat derivative. So take your derivative. I take my 2, bring it down front. 2 times 3.6 t to the 1. So I'm doing the power rule. What's 3.6 times 2? 7.2 times t minus 2.4 times 3. What's 2.4 times 3? 7.2. T to the 3 minus 1, so that's t squared. So now I have an equation for v, right? Sorry, my minus sign looks kind of like an equal sign. How do I find when the velocity is 0? Plug in a big fat 0. So 0 equals 7.2 t minus 7.2 t squared. How do I solve this? I suspect this is where the question comes. Take a t out? I can take a t out. 0 equals t times 7.2 minus 7.2 t. Yeah, you can think about it, but think about it works for certain people. It doesn't work for everybody. If I just gave you the answer, okay, from here, just think about it, I would smell a lot of burning. Smoke coming out of ears. Okay, so I just factored a t out. Yeah, so this is still the same thing. I could have factored out a 7.2 t. Yeah, how we want to do it. So from this, I should be able to see that if t is equal to 0, then 0 times whatever this is times 7.2 still gives me 0. So one way that I can have t have v equal to 0 is if t equals 0. So I'm going to have two things that are equal to 0. I'm multiplying these two things together. This can be 0, or this part in parentheses can be 0. I could have 7.2 minus 7.2 t equal to 0. So I solve that equation. 7.2 equals 7.2 t. Solve this for t, and I get t equals 1 second. So my velocity is apparently 0 at t equals 0 seconds, or t equals 1 second. So there's two answers to that one. And it even tells you in the problem that there's 2 times when the velocity is 0. How nice is it? I might not be so nice. Next, we're asked to calculate the position for each of those times. How do I get the position at those times? That very top equation, that's the position equation. So plug in 0 and plug in 1. Okay. All right, let's call that one done. Problem number 41. Next, we will try problem number 79. Problem 2, number 79. An engineer standing on a bridge drops a penny toward the water and sees the penny splashing into the water 3.0 seconds later. So I know there's a change in time that's equal to 3.0 seconds. How high is the bridge? Holy crap. They only gave us one thing. I don't know what to do. We'll be here a long time. I have no clue how to do this one. Okay, we're dropping a penny. We're dropping something. Something's falling. Something's moving with a constant acceleration. Are there any equations that tell us about how things move with constant acceleration? Yes? How many equations tell us how things move with constant acceleration? 4. What kinds of variables do we write down in those 4 equations? Usually there's a change in x, or this is dropping something. I'm going to use change in y. Okay? There's a change in position. There's some initial velocity. There's some final velocity. There's some acceleration. And there's some change in time. So these are all the variables that go into those 4 kinematic equations. Anytime you have something moving with constant acceleration and motion, write down all these variables, whether you know what they are or not. And step through and figure out as much as you can. Change in time, 3 seconds. We were given that. Change in y, that's what we're looking for. That's my demented question mark. V0, the initial velocity. How fast is it initially going? How do we know it's 0?
Because it's addressed.
Because he just drops it. 0. Okay. V initial equals 0.0. What are the units on that? Meters per second. What's the final velocity? We don't know. This is something that's tricky about these kinds of problems. So I dropped my pen. It bounced, but it hit the ground, so I would say the final velocity right now is 0. When you're talking about physics, though, it's not talking about the velocity after it hits the ground. Once that happens, the physics is done. It's talking about the velocity that it had right before it hit the ground. Split second before it impacted. Okay? So we don't know the final velocity. We don't know what that is yet. And the acceleration. Do we know the acceleration?
Yes.
Yes? What is the acceleration? 9.8? Negative 9.8? Does it matter? Yes, it does. Draw my reference grid. Here's my reference grid. Okay. We know there's a 9.8. Do we know the units of that? Meters per second squared? Okay. I have to pick directions for being positive and negative. Usually what I do is I pick anything to the right is positive, and anything up is positive, anything to the left is negative, anything down is negative. So that means the acceleration is negative. Yes? If you're using my convention, you really don't. If you're going to use a different convention, then you should. Okay. So my acceleration here would be negative, just because I'm saying down is negative. Okay. I'm looking for change in y. I know v0, I know a, I know change in t. So I need to look at my 4 kinematic equations and find the one that doesn't have vf.
I reckon we should memorize those equations.
You what?
We should memorize those.
I would definitely memorize those 4 equations. I would know them forwards, I would know them backwards, I would know them up, down, left, right, in, out. Somebody asked a good question, because there's lots of equations in these chapters. So any equation that you use to solve a homework problem, you should memorize that. Best way to memorize it, works for me at least, make note cards and review them. A few minutes every day, multiple times every day. Do that for when's the exam? Exam's Thursday. Make your note cards today. Start doing that today. By Thursday, you should have them all memorized. And definitely invest in that, because we're using these equations in the next chapters too. They're not going to go away. If you don't learn them now, then you're really screwed in the future. Okay, so what equation can I use?
The initial plus half acceleration t.
Okay, so the one that that Owen was saying, the one I would use, y minus y0, that's change in y, equals v0, change in t, plus 1/2 a, change in t, squared. Yes? V final equals v naught plus a delta t? You could do that. So I could use v final equals v initial plus a delta t. That would give me V final.
Yeah, so would it be easier once
And then you can take that and plug that into change in Y, because you're looking for change in Y. That's fine. You can do it that way. This will just give it to you in one step. Okay? Multiple ways to do all these problems. So change in Y, V naught delta T. What's V naught times change in time? What's V naught? 0, so that's going to be 0, plus 1/2 times negative 9.8 meters per second squared times 3.0 seconds squared. And I will get my y minus y0. When you plug all of this into a wonderful calculator, I'll get negative 44 meters. Okay. Plug and chug. The tricky part with these ones is to find which equation to use. Like Anwar said, you could use V final first and find V final, and then use that to find delta Y. That'd work. Okay. Any questions on this one? Yes.
To answer this question, you would say the bridge is 44 meters high.
Right.
Instead of just like leaving that box. That's
You could just leave this. I know that that's the bridge height. That's okay. As long as you circle it. What happens if you don't circle it? 0. There you go. It's the quick, easy answer. All right. So that we get to some of chapter 3, I'm going to skip one of the problems that somebody requested in chapter 2 that I had marked. We'll go back to it if we have time. Let's go on to chapter 3. Somebody asked about chapter 3, number 17. So do chapter 3, number 17. A displacement vector has a magnitude of 12 kilometers in the direction 40 degrees west of north. What is the north component of this vector? What is the west component? Okay. I suspect some multiple people are having problems with this one just because of the wording. So I'm going to draw my coordinate grid. North, south, east, and west. It's basically just a compass. Okay, and they tell us in the problem that we have a displacement vector with a magnitude of 12 in the direction 40 degrees west of north. Okay, that's the code that tells us exactly how to draw this vector, west of north at 40 degrees. So the second part of that, of north, that's the direction you want to start from. I want to start from going north. So I'm going to start going up. And then I need to move west of north. So if I'm moving west of north, do I move my arm this way or left? Or left? How many degrees left? 40 degrees. So I'm going to move my arm to get my vector 40 degrees west of north. 40 degrees west of north. Let's take an aside. And what if I said the vector was 20 degrees south of east? What direction do I put my arm in first? East. South of east. So of, and if I'm going south of east, where do I go, down or up? I go down. We'd have a 30-degree angle right there. Okay? Of is the direction you started, and then you move left or right, east or west, north or south, based on the direction you're given. We are asked to find what is the north component of this vector. So I look at this and I see something moving at an angle. You're going to have to get very used to this. We're going to do this a ton over the next couple of weeks. You're going to get so sick of it. I'm already sick of it. We have to find the right triangle in there to find the components. So I have to find a right triangle. I can draw pieces of this to get me a right triangle. If I can imagine, I can only move in the north, south, east, and west directions. So I can't actually walk at this angle. I have to walk either up and over or over and up to get to that point. I have to draw a right triangle that has this as its hypotenuse, this as its longest side. So do you want to go up and over and up? We'll go up and over. That seems to be consensus. So I can go up a little bit. And I can go over a little bit. They give us in the problem that the magnitude of that vector is 12 kilometers. And they ask us to find the north part and the west part. Which one is the north vector, blue or green? Blue is north. Which one is the west vector? Green, process of elimination. How do I find the blue vector? Trig function. Which trig function can I use? Cosine? Sine? Cosine? Sine? We have like people competing, like dancing back and forth. Close your eyes so that you can't see what other people are saying. If you think it's cosine, raise your hand. I'm going to make everybody vote, so.
We're doing north, right?
Yes, north, blue vector. Raise your hand if you think it's cosine. Okay, put your hands down. Raise your hand if you think it's sine. Okay, open your eyes, everybody didn't vote, whatever. I'm not going to waste your time. If I don't know trig very well, then what I just start doing is I just start throwing out trig functions. I usually start with sine just because I think of SOHCAHTOA, so I'll start with the sine. Sine of 40. Okay, sine of that angle. What is the sine? Opposite over hypotenuse. What's the opposite side from that angle? West. What's the hypotenuse? 12. I can solve this for west, and I will find that the west vector is 7.7 kilometers. So west was sine, which means that north was cosine. The cosines take it. Cosine of 40. What's the general definition for cosine? Adjacent. I look at my angle. My north side is adjacent to my 40 degrees. So it's got to be north divided by my 12. I can shuffle this around, do my algebra and solve, and find that the north vector is 9.2 kilometers. Right triangle trig. It's going to be a huge part of physics for the next 2 months. Finding these components, breaking things into components. You'll be as bored with it as I am. Okay. Next, we're going to try to do number 20. Number 20. Chapter 3, number 20. This is an air traffic controller, and he describes the position of an airplane relative to the airport by altitude, horizontal distance, and bearing. Suppose an aircraft is at an altitude of 500 meters, distance 15 kilometers, and bearing 35 degrees east of north. What are the x, y, and z components of the position vector? The x-axis is east, the y-axis is north, and the z-axis is vertical. This one's only tricky because you have to think in 3D. That's the hard part of this one, I think. So let's draw a picture of what we have going on. Let's draw a coordinate system. Apparently I'm drawing in blue today. Usually we draw the x and y axis, right? And the y is usually north and south. X is east and west. So if I have this drawing, then where is z? What is z? Z is like coming out towards you. For the purposes of the plane, the way to think about it, the plane travels in 3 dimensions, right? Imagine this is the plane that the plane is traveling on. Okay, so if I can imagine drawing an x-axis that goes left and right, the y-axis that goes up and down, and then the z-axis is how far above the table I am. So my plane could be up here, yeah, flying along. So out of all these numbers they give us, the z position is actually the easiest one to find. The z is how tall I am, how high above the ground I am. What is my z coordinate for this problem? 500, because it's the altitude. So z is equal to 500 meters. If we had good tech here at Marymount, I could show you a 3D picture that I drew. I drew a 3D picture, and I could rotate all around, and you could see the plane's vector and stuff, but the computer is updating, and I can't get into it. So I can't show it to you. If you come to my office, I can show you that. And I'll share my trail mix with you. Oh boy. Okay. So we have this plane, it's flying up here, but we also have something that's going on in the actual plane itself. North, south, east, and west. What direction is this plane traveling in? 35 degrees east of north. So how do I draw that on here? Of north, so start off north, and I'm going east of north, so do I go left or right? I go to the right. So I'm going to draw an angle right in here. And my plane is at 35 degrees east of north. How far away is it? What's the size of this vector that I drew?
15 kilometers.
15 kilometers. Okay. How do I get to that 15 kilometers? Do I go up and over or over and up? Let's go up and over. This time we'll go up in green, and we'll go over in red. And now we have east vector, and we have north vector. Let me do what I usually do when I have no idea what's going on and just start randomly writing things. I have a triangle up there. Anytime I see a triangle, I want to write sine, cosine, and tangent. It's just how my brain works. That's how I get my jollies. So I write, start with the sine because of SOHCAHTOA, sine of 35. The opposite side. What side is opposite to the 35 degrees? East. What side is the hypotenuse? How big is it? 15. I can solve this for east, can't I? Oh, yeah, I can. I have a PhD. Can you solve it for east? Yes, hopefully. And what do you find for east? You find 8.6 kilometers. And you circle it so that I will grade it. Then we can write cosine. wonder if that yawn will show up on the recording. Heard people yawning. Cosine of 35. Cosine is the adjacent side. What side is adjacent? North. North side. What side's hypotenuse? How big? 15. Solve this for north and you will find 12.3 kilometers. Let's say I told you to obey sig figs on this problem. Would you get full credit? How many sig figs should you have? 2. So what would be this answer if you obeyed sig figs? 12. Okay, so that was number 20. Next, let's do number 31. This is one multiple people asked about. I think it's more because of the math and not because of the physics. We have 3 vectors given by A equals 2.0 in the I hat direction plus 3.0 in the j hat direction plus 1.0 in the k hat direction. We have another vector B that's negative 1.0 in the I hat plus, I don't know, I'm probably mixing them up. I started mixing them up. Skip this slide, ignore what I just said, and go to the, fast forward a little bit. I'm recording, so getting that recording on there if you're reviewing later. Now we'll actually do problem 3.31. 3 vectors. A is 2.0 I hat plus 3.0 j hat. B is 1.0 I hat plus 5.0 j hat. And C is equal to negative 1.0 I hat plus 3.0 j hat. And I am asked to find constants C1 and C2 so that C1 times A plus C2 times B gives me C. I want C1 times A plus C2 times B to give me C. Okay. So this is really testing how well we know to add vectors and vector components. I can only add components of vectors that go in the exact same direction. So let me write out these vectors as an addition problem. I'm going to multiply my C1 into my vector A. So C1 times A is going to give me C1 times 2.0 in the I hat plus C1 times 3.0 in the j hat. Yeah. C2 times B is going to give me C2 times 1.0 in the I hat plus C2 times 5.0 in the j hat. And when I add these together, I know I'm going to get C. And what is C equal to? Negative 1.0 I hat plus 3.0 j hat. Okay, so when I can use this, the way I've written this, I can separate things up into their components. I can only add components that are going in the same direction. So everything in the I hat is going to add together to give me negative 1 I hat. Everything in the j hat is going to add together to give me 3.0 j hat. So I can write and do equations from that. I can do just the I hat stuff and just the j hat. It's kind of like this column and just this column. And now it's Christmas. Red and green. Be all jolly. So I can write out two equations. First equation I can do, C1 times 2.0 in the I hat direction plus C2 times 1.0 in the I hat direction has to give me negative 1.0 in the I hat direction. Yes?
How do you get negative 1i from 2 plus 1?
So this C1 and this C2, these are numbers. So you're going to multiply these numbers into these so that you will end up getting negative 1.
Okay.
I think that's the first time this semester where I actually believe that I really answered your question. I never think I answer stupid questions. So, second one, j hat direction. I have C1 times 3.0 in the j hat plus C2 times 5.0 in the j hat direction is equal to 3.0 in the j hat direction. Alrighty. How many unknowns do I have between these two equations? 2? What do I not know? C1 and C2. It didn't register. My iPad's going bad. They should buy me a new iPad. Or the iWatch. Could you imagine that? Doing everything on the iWatch. That would be insane. So I have two unknowns. I don't know C1 or C2. How many equations do I have? Two equations. Two equations, two unknowns. I can solve that. I have a PhD, so I can solve that. Anybody in here have a PhD? One. Okay. So one person in here can solve that. Can you solve this?
Yeah.
Close your eyes. Everybody close your eyes. Really this time. Close your eyes. How many of you can solve this? Put your hands down. How many of you don't think you can solve this and want to see it? Okay. That's what I thought. So what I have to do is I have to solve one of the equations for the unknown variable and plug it into the other. I picked the first equation that I wrote, so I picked C1 times 2.0 plus C2 times 1.0 equals negative 1.0. So this was the equation going on in the I hat direction. And what I did, I solved this for C2. How do I get C2 by itself? Subtract C1 times 2.0 from both sides. Rules of algebra, if I do it to one side, I have to do it to the other. So I find that C2 is equal to negative 1.0 minus C1 times 2.0.
You can just drop the i's and the j's.
Yeah. So now I can take this and I can plug it in to my other equation. My other equation was C1 times 3 plus C2 times 5 equals 3. So C1 times 3 plus negative 1 minus C1 times 2 times 5 equals 3. Yes.
Wasn't it C2?
I have C1 times 3 plus C2 times 5 equals 3.
She's talking about the first one. Yeah, the first one.
C1 times 2 plus C2 times 1 equals negative 1.
Yeah, you should write the 1, so it's
Okay, here. 1.0. Okay, so now I took this C2 and I plugged it in right here to get to this. All very methodical, will always work. C1 times 3 plus -5. I have to distribute that 5 into everything in the parentheses. Minus C1, 5 times 2 is 10, equals 3. I can combine my C1s, can't I? I have 3C1 minus 10C1. What's that? -7C1. I assume that's what you said. It really sounded like you were saying Susie sold seashells by the seashore. I just heard a lot of s's. Okay. So I combine my C1s, -5 equals 3. How do I solve this for C1 now? Add the 5 to both sides. So I do that. I have -7C1 equals 8. So I find that C1 is equal to -8 divided by 7. And if you type this into a calculator, you'll probably find that it's -1.1. So that's my C1. C1 is -1.1. Yes?
Did you just cancel like the J's out, or you took them out in that equation?
Yeah, you don't need to use the J's. You separate into I and J to actually get the equations, but then as long as you're working with these individually, the direction doesn't matter. If you want to keep them in, you can. So we'd have a J hat here, a J hat here, and a J hat here. But if you have the same thing in all of them, you can divide it out. And do a little. I have C1. How do I find C2? Plug it in right there. So that's a plug and chuck. I'm not going to do the plug and chuck. But I will give you that C2 ends up being 1.2. Okay. This is a very math-heavy question. It tests if you know math. It tests if you can take a logical process and apply it. All right, that was number 31. Next, let's try another. Let's do number let's do 75. Chapter 3, number 75. The displacement vector A has a length of 50 meters and a direction of 30 degrees east of north. The displacement vector B has a length of 35 meters and a direction 70 degrees west of north. What is the dot product of these vectors? It's fun to watch students. Some of you have your game faces on. Some of you are. We got the single boredom, we got the double boredom. And then we have the giggles that are humoring me. They're the ones that are going to get A's. So let's draw a picture. Figure out what these vectors are. We have vector A, and vector A is going at 50 meters, the length of 50 meters, at 30 degrees east of north. Okay, so when we've had a question like this before, we've always drawn a picture, right? We draw a coordinate system. Let's draw a coordinate system. I got to go 50 meters at 30 degrees east of north. So where does my hand go for the beginning? Where does my arm go? It goes north. And do I go east or west? Go east. By how much? 30 degrees. So I go 30 degrees east of north. And I get a vector that looks like that. 30 degrees. Some bit of it is going up. Some bit of it is going over. They gave us that this vector A is equal to 50 meters. So I'm going to call these two other vectors, these two pieces, these two components, AY and AX. Can I find what AY and AX are? Yeah, I can find it. I can use trigonometry. I start with sine of 30 because I always start with sine because SOHCAHTOA. Sine is opposite over hypotenuse. Opposite side here looks like it's AX over 50. So I get that AX is equal to 25 meters. And then I do the cosine. So I get adjacent over hypotenuse. Looks to me like it's AY over 50. So I find that AY is equal to 43 meters. And then poor Tola, he's left out in the dark. We never use Tola. We already know everything. Okay, when I'm doing dot products, usually, because this asks us to do a dot product, I usually don't see things written like AX and AY. What do you usually have for dot products? I's and J's. So I need to write this vector in a slightly different format, slightly different way. I need to write the vector A in its X and Y components. Its I and J components. How big is its I component? 25. So this vector A, 25 in the I hat direction, plus how much in the J hat? 43 in the J hat direction. Okay. Now this isn't my final answer, but I like to circle intermediate steps. You are welcome to circle intermediate steps. I won't count off for that. Okay. So that's my A vector. I need to get a B vector too. So let's get the B vector. B is equal to 35 meters at 70 degrees west of north. Draw my coordinate system. Start off going north. I need to go west of north, so this is going to be my angle. Break it up into BX and BY. So I'm just applying the same process that we've done many, many times already. Sine of 70 is going to be bx over b. So I end up with bx is equal to negative 33. Ooh.
Yep.
How did I get that? You just plug it into a calculator and you get that.
No, I mean, you take it direct.
What happens if you plug it into your calculator? It's positive. I put a negative on there.
Going in the next one.
Yeah? I'm allowed to do that? Yeah. This is why we draw pictures. This shows us that they're going in opposite directions. Okay? So the math might not give you that it's negative. What you have to do is look at the physics, look at the picture of what's going on. You know it's going in the negative direction, so you have to smack that negative on there. Smack the negative. trying to have fun up here. It's not working. Cosine of 70 is going to be by over b. By is going to be equal to 12. So my b vector now is going to be negative 33 in the I hat direction plus 12 in the j hat direction. Now I have to take this dot product. If I take the dot product and I get 0, what does that mean for these vectors? It means they're perpendicular. Okay. Let's see if they're perpendicular. A dot B is going to be 25 I hat plus 43 j hat dot negative 33 I hat plus 12 j hat. I have to multiply these numbers out. The unit vectors will multiply together, cancel out, give you 1. 25 I hat times negative 33 I hat. What does that give me? What's 25 times negative 33? Should be negative 825. What units? Ooh, I've dropped units when I'm solving. I hat times I hat. What's I hat times I hat? 1. I dot I is 1. They're parallel, same direction. You get 1. Meters? What are the units of the A vector? 25 meters. What's the units of the B vector? 33 meters.
Meter squared.
Meter squared. Vector A is in meters, vector B is in meters. You multiply them together, you get square meters. Okay, 25I times 12J. What do I get? What's 25 times 12? No. Well, 25 times 12 might be 300. 300! Oh. My abs look like abs from 300. Ask my what? 0?
300K.
K? What do I get? The last one we did I times I gave me 1, right? I dot I is 1. Okay? I dot j, what does that give me? Gives me 0, because they're perpendicular. Okay? So 25I times 12j gives me 0, because they're perpendicular to each other. Okay? Maybe we need to write this out. I dot I plus 25 times 12 meters squared I dot j. Okay. What direction does I usually go? If I was going to be the coordinate system, what direction would I go on the board? I is like this. What direction is j? Up. How are my arms related to each other? Are they parallel? Perpendicular. What's the dot product when you're perpendicular? 0. So I dot j gives me 0. This goes away. Yay. Okay. So now I need to distribute the 43 plus 43 times negative 33 times j dot I. What's j dot I? 0 goes away. Plus 43 times 12 j dot j. Okay, I dot I think I already said this. I dot I is 1. J dot j is 1. Any unit vector dotted with itself is 1. So What's k dot k? 1. What's k dot k dot k? Ooh, that's not a good one. KKK. I didn't do that on purpose. I didn't. Ooh. What's I dot I dot I? I. 1. What's j dot j dot j? J. 1. Okay. Whew. That's gonna look good on my evaluations. What's 43 times 12? 516. So this number right here becomes 516. And we do 516 minus 825, and we get a final number for A dot B is equal to negative 309 square meters. Make that dot a little bigger. Yes?
So is it only when we're doing the cross vectors when we do like the definition where it's like I, J, K?
Yeah. Cross products are the only time you do I cross J equals K. J cross K equals I, yes.
On the test, will we have to use this method or can we use the definition of a dot product?
You could use A, B, cosine theta.
Alright.
That's fine. Okay.
Is that easy? How would you do that?
How would you do that?
So you just do the cosine of,
Multiply them all together and then cosine of theta. Cosine of the angle between I and I would be cosine of 0. And that gives you 1. Cosine of the angle between I and J would be cosine of 90. Would give you 0. Yeah.
Well, couldn't you take the angle between the A, like couldn't you take like 35 and then like the difference between the angles and then do the magnitude?
I have to think about that.
Because that's how the, I don't know, it's just,
I'd have to think about it and look at it.
okay.
Yeah. Any other questions? We've got like 5 minutes left. That's really not enough time to do any more problems. If I didn't get to the problem that you wanted to see, talk to me in office hours. What? Before you pack up,
Is there any way you can put that 3D model on the website?
I can do that. I'll make a screencast explaining it and pop it up on the web. All your quizzes are up there. So if you have any questions, let me know.
Are you doing the virtual?
I'm going to start those for the next minute. It'll probably be on Tuesdays from like 9 to 10. And then Sundays probably 8 to 9 or 9 to 10. That's after my wife goes to bed, so I'll be whispering. Yeah.